Okay, guys, so in this lesson, I would like us to look at how we can find the first and second derivative of the function. So in finding the first derivative of the function, we already know what to do. So f prime of x is equal to, as you already know, this power here 3 must multiply the coefficient here. So the coefficient here is 1. So it becomes 3x, and then you have to subtract 1 from the power. So 3 minus 1 will give us 2. Now when we come to this part, we multiply this power by this coefficient here. It gives us minus 4. Then we subtract 1 from the power, so 2 minus 1 will give us 1. So it means 4 minus 4x to the power of 1. And then here, 1 is the power, times minus 5 will give us minus 5. But now we have x to the power of 1. Now, the original power 1 minus 1 will give us 0. So x to the power of 0 will give us 1. So basically, x to the power of 0 gives us 1. So 1 times minus 5 gives us minus 5. As we can see, this is a constant. It doesn't have any variable or x per se attached to it. So we already know that the derivative of a constant is 0. So the derivative of 6 is 0. So this is the first derivative of the function. Now, if you want to find the second derivative, we can equally put f prime prime of x, then we say equal to, then we take the power again. That is the rule per se. So the power times the coefficient here, so 2 times 3 will give us 6, and then x. Now we subtract 1 from the power, so 2 minus 1 is 1. So it means x has a power of 1, no longer 2. Now, x has a power of 1. If we subtract 1 again, it will give us 0, meaning x to the power of 0 is 1. So we now have the power 1 times minus 4, which gives us minus 4. Now we subtract 1 from the power, which gives us 0. So x to the power of 0 is 1. 1 times minus 4 gives us minus 4. In this case again, there is no variable or x attached to this minus 5. So this minus 5 becomes a constant. Therefore, when we derive a constant, the result is 0. So the derivative of minus 5 is equal to 0. So the second derivative of this function here is 6x minus 4. And the first derivative of this function is 3x squared minus 4x minus 5. Now, why are we trying to look at the first and second derivatives of a function? They are very important because when you are dealing with a cubic graph, you will need to consider the turning point. You also need to consider the point of inflection. We will talk more about that in the next lesson. But what we can say now is that whenever you are looking for the x coordinate of the turning point, you need to consider what I'm trying to explain here. So these are the two things that we need to know when we're talking about first and second derivatives of a function. In our next lesson, we will look at how to determine the x coordinates of the turning points, the two turning points of the cubic graph, and also the x coordinates of the point of inflection. Mind you, when you are dealing with a cubic function or a cubic graph, there are two turning points originally of a normal cubic graph. Though there are instances where you'd have a bit of funny sketches, but the basic and normal cubic graph that we know has two turning points. And therefore, when we looking at the x coordinates of the turning point, we will be looking for two x values of the two turning points, or the x coordinates of the two turning points. And once we have two turning points, basically we will have one point of inflection. The point of inflection actually is equidistant between the two turning points. What I mean is that the distance between the two turning points of the cubic graph has the point of inflection lying directly at the midpoint between the distance that lies between the two turning points. So when you are moving from one turning point of a cubic graph to the second turning point, in between the journey, I mean equidistant, or the midpoint of that distance, is where the point of inflection lies. But we will talk more about that in our next lesson. Thank you.